Hello everyone, welcome to the tutorial series of Python language quantitative trading practice. In the last lesson, we have learned about logical operators, arithmetic operators, and comparison operators. And today, we will continue to learn the ternary operators. A ternary operator means that the operator requires three elements to form an expression. We write it on the strategy editing page here. The ternary operator is mainly composed of a question mark and a colon. The first element is to judge the expression. For example, here we judge A. If the judgment is true, let the expression result return to B. If it's false, let the expression result return to C. Then the combination of the question mark and the colon is called the ternary operator. Ternary expressions have also been used for many times in our previous lessons. So let's review the usage of ternary operator through a simple example. If I want to determine whether each k-line bar is positive or negative, declare a variable a on each k-line bar to determine whether close is greater than open. And then declare a variable b. And we use a ternary expression to determine whether A is true, that is, A is true when close is greater than open, that is, the current k-line bar is positive. We will let this ternary expression return to a string positive. If the current k-line bar is negative, we will let this ternary expression return to a string negative line. The variable b here is mainly used to store the results. Then we declare a variable c, which is also demonstrated by a ternary expression. The expression passed in here cannot only be a logical value, but also an expression. For example, we use not a. If a is true, it is a positive line. When a is false, it is a negative line. So when the expression c is established, it is a negative line here. We let it return to a negative line string. If not a is false, that is, a is true. So close is more than open holds. It is a positive line. and we let it return to a positive line string. We use the plotChar function to draw the information to be printed. We draw A first. We specify its location above the k-line bar when A is true. Specify its color as red here. And assign the variable b to the character char. And let it draw on the main chart. Then we use the plotChar function to draw the negative character. If it's negative, that is, not A is true, specify its location at the bottom. Specify its location below the k-line bar. We can copy it. Here is not A. Below the bar. Specify the color as green here. We change it to green. And assign the variable c to the character char. Specify it on the main chart here. This is a demonstration of application of the ternary operator, and we click backtest after add any exchange. Here we have add balance, and we can click backtest. Wait for a moment. We can see that it prints positive lines all over the k-line bar when the k-line bar is positive, and it prints negative lines all over the k-line bar when it is negative. Ternary expressions can be used individually or nested. As we have mentioned in many previous examples. For example, in this case, it could be a positive line, negative line, or a cross. If I want to determine the state of the cross and draw it out, then here we just need to do a nesting of ternary operators. So what do we need to do to change it? When it is a positive line, we add a condition to determine whether it is a cross. We modify it directly in this place. And then we write a ternary expression to let it be the result returned. That is, we judge it again in the condition branch, and we judge the cross with the function mathAbsolute here. That is, we judge its absolute value. We determine the difference between close minus open. and whether its absolute value is greater than 30. If so, then it is negative. If it's less than or equal to 30, then it is a dodgy here. Don't forget. Similarly, in this place of the negative line, we need to modify it too, because it could be a negative dodgy. We use another bracket and use math absolute function. Close minus open. If so, if it's more than 30, then it is negative. If it's less than or equal to 30, then it is a dodgy here. Likewise, the expression below C here is also needs to be modified too. We can simply change the negative and positive lines to the same as above. We can copy and paste them directly. C equals to not A, we use math absolute functions. Close minus open more than 30. Here is negative line or dodgy. And then it is positive line here or dodgy. Then we click backtest to test it. Oh, it reports error. Let's go back to the code page to check it. We lost the question mark here, and we add them to the expressions here. Then we click backtest again. We can see that in the chart there is already content output. Because the price fluctuations with 1 minute is relatively small, so many of the K-line bars are identified as a dodgy here. And we change the k-line period to 1 day here. And click backtest again. We can see that the absolute value difference between opening price and closing price is small. It will be identified as a doji. Other positive. Here a doji and here. Other positive lines and are identified as positive lines, and the negative lines are identified as negative. For example, in this case, it looks like a doji here, but it was identified as a positive line because it has an opening closing spread greater than 30, which is related to the value we set here. That is the difference between the opening price and the closing price of the doji as we define it. This is what we talk about the using of ternary expressions. Next, let's move on to the historical operator, which has been used in many of our previous code examples, and it is represented by a bracket. And it uses the history operator to refer to the historical values on the time series, which are the values on the k-line bar before the current k-line bar at the time the variable was run in the script. The historical operator can be used in variables, expressions, and brackets after function calls, and the value in the brackets is the offset of the historical data we want to reference from the current k-line bar. For example, if I want to quote the closing price of the last k-line bar, we can write close 1. Which is the closing price of the previous k-line bar on the current historical k-line bar. For example, if I want to take the highest price of the first 10 k-line bar from the current k-line bar, we can write high 10 brackets. Like this, if I want to get 10 periods of the SMA average of the current k-line bar of the last k-line bar corresponding to the value of the SMA average, first we use TASMA function to calculate the indicator data of the SMA. And then make a historical reference to it, use the brackets, quoting the current k-line bar of the previous corresponding indicator value, like this. In addition to this, there is also the TA highest function that we often used, which we have also talked about in the previous time series course. For example, here we calculate the maximum value of highest price on the previous K-line bar within 10 periods. Of course, it can also be written as these two expressions here are totally the same. In fact, it is the use of the historical operator. We can use the function to calculate it, or we can pass in the quoted historical data directly and then use the function to calculate. These two ways are exactly equivalent. Again, the historical operator can only be used once on the same value. And if I declare a variable a and referencing close on the previous historical K-line bar, then we add a historical operator to it and write 2. Here a equals to close 1 brackets 2 here without space. It will report an error definitely because it can only be referenced once on a variable using the historical operator, the time series we talked about before, which is actually different from an array. Let's illustrate it by an example below. First, we declare a variable. First, we write a strategy test here. And let it draw on the main chart. Then we declare a variable a equals to close. And declare a variable b equals to referencing a period before with the historical operator. And variable c here, referencing a period before b with the historical operator. And we draw variables a, b, and c, all them all on by the plot function. Name it as a here. Title equals to a. Here is b. Name it as b. And here is c. Name it as c here. So let's compare these drawn lines and their differences. We click on Backtest. And we can see that our charts has been drawn out. There are 3 lines in total, A, B, and C. But the changes of these 3 lines are exactly the same, except each line is delayed by 1 period from the previous one. We can see that the purple one, line B, is delayed by 1 period from the yellow line, line A, and the blue line, line C, is delayed 1 period from the line B, and the line C is delayed 2 periods from line A here. If they are shifted, they can be coincide completely. So why is there such an effect? Let's go back to the strategy code page. We can see from the code that C here, if we write C equals to B, the previous k-line period, if we write C like this, it will report an error absolutely. But if written separately, it will not report an error. If we understand it according to the usual error, after the assignment of B equals to close the previous k-line bar, B should be a value. But C equals to B, the previous historical k-line period, B can still be used to refer to the historical value again by using the historical operator. It can be seen that the concept of series in the Pine language is not as simple as an array. It can be understood as the historical value on the last bar of clause assigned to B. B is also a time series structure, and its historical value can continue to be referenced. So we see that in the drawn 3 lines. A, B, and C. Line B is 1 bar slower than line A, and line C is 1 bar slower than line B. The line C is 2 bars slower than the line A. We can pull the chart to the far left and observe that on the first k-line bar, the values of B and C are both null here. That's because when the script is executed on the first k-line bar, it does not exist when referencing to the historical value of 1 or 2 periods forward, which does not exist. Therefore, we need to always pay attention to whether the null value will be referenced when referencing to the historical data. When writing the strategy, if the null value is used carelessly, it will cause a series of calculation differences and may even affect the real-time bar. Usually, we use built-in functions such as NA, NZ. To judge in the code. In fact, we have also touched the previous bar of the clause built-in variable. We can see NA. If we put our mouse here, it will display it will display it. Deal with the case of null values, for example. Close more than NZ. Okay. That is when referencing the historical value of the previous bar of the closed built-in variable. If it does not exist, the open built-in variable is used. This is a handling of possible references to null values. We have already explained the basic use of all operators. There are also reader comments in our video. When these operators are mixed together, what order of operations is required? Just as ordinary programming languages. In Python language, operators also have precedence. We have learned a lot of Python language operators. These operators form expressions through various combinations with operands. So what is the priority of these operations when evaluating in expressions? For example, when we were in school, we learned the 4 operations: multiplication, and division are calculated first. Then we calculate addition and subtraction. The same is true of expressions in the Python language. First, multiplication and division. Secondly, the addition and subtraction. The operator with the highest priority is the history operator brackets. Then the addition and subtraction and not in the unary operator. By the way, there are 9 levels of the operator priority. The 7th are multiplication and division and modulo. The 6th is R. The 5th is addition and subtraction in the binary operator, and the 5th are more than, less than, more than or equal to, less than or equal to. And the 4th are equal and not equal. The 3rd is and. The 2nd is or. And the first is a historical operator here. A part of this expression with higher precedence is evaluated first. The brackets is evaluated first, and if the precedence is the same, it's evaluated from left to right. If you want to force a part to be evaluated first, we can use parentheses. Write it here. We can use parentheses to wrap the expression to force the part to be evaluated first. So the above is the course of all operators. If you have any valuable comments or suggestions, please feel free to leave us a message or what aspects of learning needs. We will produce more useful video tutorials. Thank you all and see you in the next video.